everyone, it's Michelle
and Steph,
and welcome back to the Inspired Podcast, a podcast hosted by UVic's Inspire program, which focuses on STEM for social impact. This season, we're stepping beyond the syllabus and engaging in conversations with some of your favorite professors.
Okay, well, welcome. My name is Trefor Bazett, and I've kind of got two weird roles. I'm an assistant teaching professor at the Department of Mathematics and Statistics here at the University of Victoria. And then I have this weird sort of like side job, I guess, which is that I am sort of a math YouTuber. And so I'm doing a lot of like math outreach stuff, putting up on YouTube and trying to sort of be in that social media space where I think a lot of students tend to hang out.
Yeah, I definitely don't think you can understate that. You're definitely a very...
Oh, you're very popular.
A popular YouTuber. I think a lot of
people
UVic
were excited.
Students, oh, yeah.
It is always funny walking around on campus and students who don't know that I'm a professor here at UVic, and then they come for the first time and they see that I'm a professor at UVic, and they're like, oh, I totally know you. I got through whatever, my calculus or something like that.
Exactly.
From your videos.
I knew that you were a YouTuber. I'd seen you, and I knew that there was a YouTuber that like went to UVic that was a professor at
not
UVic.
That they're the same
Yeah,
person.
I didn't connect those.
Okay. So I wanted to ask, I know you're on study leave right now and that you've been excited to focus on YouTube during this time. So I wanted to know, why are you so excited to focus on YouTube?
Well, because I have both of these different roles, being a professor as well as doing stuff on YouTube, it's always felt that the professor job should and does come first. Like, I have students who have paid money to be in my classes. Like, clearly I need to put the priority there. And I try to do a good job as a professor to whatever degree I can. And just the reality of is that when I do that, there's just not a lot of time to be able to do the YouTube stuff on the side. So it's a lot of sort of a little bit after the kids go to bed in the evenings, on the weekends. That's when I finally find a little bit of time to do it. And as a result, the YouTube was just sort of kind of growing in the background. Like, I had released a lot of videos because of the COVID-19 pandemic and online courses and flipped classrooms. So a lot of stuff was there, but I wasn't really giving it what it was due, it felt like. And so I was having all of these comments from people who are like, I'm replacing my education at some other university around the world, and I'm going to YouTube and I really love it. And I'm like, at some point I really want to actually lean into that space. And so for the study leave, which is really nice because for a professor, basically 1 out of every 7 years you can apply to be on study leave. And in that process, you can pretty much do whatever you want to as long as your dean agrees and says that that's like a reasonable thing. Like, if they write up a proposal, say, I'm going to do all these things and this is what I want to do. And I just thought that there is a place for YouTube and it was worthwhile to invest in. And specifically, I think I feel that way because I for a long time made YouTube content that was to support classes. I was making it for my own students and my own classes, and I made it for that reason. However, I've now been trying to think about, like, where do people like find a love of math and like sustain their enthusiasm for math? Like, if you're interested in Minecraft or something like this, you might sustain that enthusiasm by like watching things on YouTube. But if it's math and there's no math in this YouTube space, what are you going to do? Now, of course, there's actually a lot of really good math YouTubers out there, but that's what I want to do. I wanted to try to have a place for people to go who are just excited about math outside of their courses. And so all of this content that I'm making over the study leave isn't really standard course content. It's just really cool, fun math stories that I get to tell and put up online.
That's super cool. Have you like gone into TikTok and stuff? Because that really supports that type of content.
Only the tiniest bit. If you search well, you'll find my 100 TikTok followers out there. But I haven't really done much. I've just a few clips from my main video that I just put into vertical format. I found for myself, I have nothing against TikTok. I think it's like really great, and I know there's some really good math-based TikTokers out there. And there's actually I know there's at least one math professor who only does TikTok, and he's incredibly good at it. For myself, the stories I've been telling have typically been more longer form. Like, I really like telling like 10, 15, even 20-minute stories. So I haven't as much leaned into TikTok, but I probably should one of these days. So maybe a little bit more. YouTube is definitely my main platform, and then TikTok's sort of like the thing I say I sometimes ought to do more of, but haven't really.
Gotcha.
Well, I can tell from just listening to you that you see something really beautiful in math. Like, it's really inspiring to you. And I know that you've described mathematics as a kind of journey. But what I haven't really done much, I've just, trying to think of where do people find a love of math and like sustain their enthusiasm for math? Like, if it's math and there's no math in this YouTube space, what are you going to do? Now, of course, there's actually I know there's at least one math professor who only does TikTok, and he's incredibly good at it. For myself, the stories I've been telling have typically been more longer form. Like, I really like telling like 10, 15, even 20-minute stories. So I haven't as much leaned into TikTok, but I probably should one of these days. So maybe a little bit more. YouTube is definitely my main platform, and then TikTok's sort of like the thing I say I sometimes ought to do more of, but haven't really.
Gotcha.
Well, I can tell from just listening to you that you see something really beautiful in math. Like, it's really inspiring to you. And I know that you've described mathematics as a kind of journey. And I think that it's something that a lot of maybe your typical undergraduate student who's just trying to get through these courses might not see when they're taking these courses. So what do you mean when you call math a journey, and why is it so beautiful to you?
Oh, that's so interesting. It's hard to know. Like in the same way, if someone said, well, why is music or art or any other sort of medium beautiful? It's hard to come up with an immediate answer to it. But I think that sometimes the learning of mathematics for our courses, like everyone has to do math in high school, and everyone, well, not everyone, but a lot of people in STEM subjects have to do math in university. And all of that formalized training can get in the way of the parts that are kind of really fun. So like almost everybody enjoys the idea of going and solving or kind of a fun puzzle or an interesting game that they enjoy playing. Or some people, for example, might spend thousands of hours playing chess as a hobby, but then would switch to mathematics and find that somehow, while having to pass this calculus test, that's actually really, that's the burden that comes in front of it. So one of the nice things about doing stuff on social media is because you don't have to pass the test, you can just focus on the stories that are most interesting and hopefully sort of take people on a little bit of a journey. And I kind of do think that math is something that is for everybody and everyone can sort of appreciate and develop an appreciation for and use in their lives. And so trying to tell those stories and get people engaged in that way, I think is beneficial. At least that's my hope.
Mm-hmm. Yeah, so just listening to you, like I'm already getting inspired, but like how did you get inspired to pursue this, your passion, the math?
Oh, I don't know. It's sort of actually hard to, it seems funny, but because I've now did undergraduate like 20 years ago, it's sort of actually hard to remember like like why. I always enjoyed math, like even from like elementary school kind of ages. Like I was associated as somebody who liked math but I feel when I was in sort of first and second year university, I actually was quite lost. I didn't know what I wanted to do. I mean, I knew it was something in that space, maybe computer science, maybe physics, maybe math. I wasn't really sure. And I actually ended up thinking more going into physics. For a long time, I thought of myself as a physicist. I have a degree that's math and physics, but in that, all of my friends were physicists, and I was a physicist. We hung out in the physics building, not the math building, all those kind of things. But sometime around second or third year, I was really just enjoying the mathematical aspect of it. And I think that when I started to see sort of common patterns that you would see in mathematics come up over and over and over again and recognize them in different physics courses as being sort of the same underlying mathematical idea, that level of abstraction I really enjoyed. And so as I went on in my undergraduate, I was like, I'm definitely going to become more of a math person. So for graduate school, I entirely applied for math. And now my physics days are a little bit behind me.
That's interesting. So you kind of emphasize that like math is for everyone, but like a lot of people just don't really feel that connection because of all like, especially exams and stuff like that. So I guess I was wondering, for those people who you make content for, especially with like specifically your calculus videos, how do you think that you approach like trying to not make anything confusing and like trying to really reach out to them in the way that maybe their professors haven't?
You know, I actually don't think that my standard course content is like that special. What I think the different, like I'm not saying I make bad content. I think I make decent lectures, but I don't know that somehow like my calculus lectures are better than calculus lectures from anyone else that's around the world. But I think that maybe what the difference is that if you're somebody who has been stressing about your calculus, is you don't have to rely on showing up into whatever university you're at in that particular time and sit there for 50 minutes while maybe the professor is going much faster than you need or much slower than you need. You don't have the ability to sort of like pause and reflect and rewind a bunch of times. So something like the YouTube and the video as a backup options to go and sort of feel comfortable with, I think helps sort of, even if my explanations are identically as good as the explanations they could receive from their own professors, it's the fact that they can sort of do it at their sort of own pace that I think makes most of the difference. That said, I do try to emphasize some things that I think help. Like I really like to emphasize the visual nature and the intuition. So often math courses get bogged down with like technical computations, and they're just kind of stuck in a lot of these things where people are following procedures, following recipes for how to do something without really understanding. So that's the one thing in my personal teaching or in my teaching online, I'm really trying to emphasize, can we have a clear intuition and geometric idea, I think that can make a little bit of a difference.
What do you do when you lose the geometric idea? If you go into like, linear algebra, for example, can get very abstract very quickly. Yeah. How do you approach that?
Yeah, it's challenging because not everything can be done this way. I mean, even something like linear algebra, so you often have clear pictures of what's happening in 2 dimensions. You can visualize it. You can visualize what's happening in 3 dimensions, a little harder, but you can usually do it. And then they say, well, let's imagine you're in a 10,000 dimensional matrix or something like this. It becomes a little thing. So I do think that at some point we need to abstract away so we can't easily visualize. But if you have the connection to the places that you can visualize that are really clear in your mind, then those steps to these more general concepts are a little bit easier to approach. So I try to focus almost sometimes even too much on this clear picture in, say, 2 dimensions, so that when you step beyond 2 dimensions, you're with me. Whereas if you just sort of glance at the 2-dimensional picture and like, oh yeah, that sort of makes sense, I can see things in 2 dimensions, then when you jump to arbitrary number of dimensions, it gets confusing.
Gotcha.
I know that you won this award, I think very recently, the Education Award.
Yeah.
Yes. What is that? How did you get that?
So the award was the PIMS Education Prize. And so PIMS is the Pacific Institute of Mathematics and Statistics. Oh, no, that's wrong. Pacific Institute of Mathematical Sciences. I better get it correct. And the focus of that award was just tailor-made to me, which is kind of funny, because it was intending to try to do people who were doing stuff beyond just their own classroom environment. So, for example, the outreach work that I was doing on YouTube is just like a perfect example of the type of thing that particular award was doing. But it was a really big honor to be able to get it because I often sometimes feel that in academia, I have my academic work and then I have the social media work, and they're very different things. And so it's really nice when those two things are sort of tied together and you have an academic group who's recognizing the sort of social media work and the power that can happen. So we just someone put in a nomination and I got it and had to go down, and they printed out, it was kind of a hilarious, one of those gigantic checks, you win a lottery on it. So I have one of those sitting in the back of my office, which I thought was hilarious.
Congratulations.
Thank you.
And then I think a lot of professors also do research as part of their job. Is that part of your job as well, when you're not on study leave?
Yeah, yes and no, depends exactly what you mean. So I'm an assistant teaching professor, and for an assistant teaching professor, 70% of your job is meant to be on teaching, 20% is service, like committees, or I would even consider what we're doing here in this little podcast to be in that category, service to the community. But 10% is what's on scholarship. So for myself, I actually no longer do pure math research. My 10% of scholarship is stuff that's all in math education. So for example, one of my big projects recently was to work on a chapter in a book about teaching mathematics online. And so as you can probably imagine, I focused on sort of video design and video creation and that kind of stuff. So it's scholarship, you're still writing a book the same way someone who is writing a book about math might do, but it's about math education instead. So that's where my chunk of scholarship is. And I have to do a little bit of that for the study leave as well. And I think that's really nice. Actually, UVic does a really good job, which is to say that for their faculty who are teaching faculty, some institutions, that's all they do. They just teach. But here at UVic, they say, well, look, if you have these other side projects that are broadly under this umbrella of scholarship and all sorts of people do all sorts of different things in that bucket, well, you have 10% of your job that you can feel like you can go and dedicate a few hours a week to doing these other things, and that will be credited as part of your program. So I really like it.
That's really cool.
That is cool. I have a question slightly off topic.
Yeah.
Do you have any people who help you edit your videos and make all that content and record, or is it just
I
you?
Wish. I have nobody. I always I bug my wife because she's been thinking about being a producer or something like this. Mm-hmm. But right now, it's just me, and it took a really long time to figure out each of those little details. Editing videos just takes me so outrageously long. I think yesterday I edited for 8 hours straight on one 15-minute video that I was trying to make out. It takes so long. But all of my old videos are terrible. They've slowly gotten better as having to learn all the aspects of the technology. That's a lot. Kind of even with this podcast here, all the different software and the hardware, and it adds up.
Yeah, I mean, that's why I mentioned it, because I know even just between Michelle and I, we didn't know anything. And at least we have each other to balance the workload here. But that's a lot of work.
And, I mean, that's part of why I felt like I needed the study leave to try to work on some of those things.
Oh yeah.
So like something I'm trying to work on right now is just actually my computer programming and my Python so that the background animations are better. Well, you can spend a huge amount of time just to make a single animation that's going to be in a video for 3 seconds, right? You could be at it for days depending on how complex it is, right?
Yeah.
So that's the type of thing where, maybe in the future at some point, I'll hire some students to come in and help me with some of those things. But right now I'm doing it all on my own. So I've got my own little studio and my green screen and my lights and all that kind of fun stuff. So I enjoy it.
That's cool.
So
future Inspire UVic collaborators.
Yeah, I think you got to put a green screen right here, and then we can go for it.
What's your favorite video you've made so far?
Oh, there's so many. How do I even choose? I think one that I really like is it's about the math of bubbles. And so, okay, so everyone knows if you blow a bubble, you make a circle. But like, what happens if you take a wireframe of a cube or a tetrahedron and dip that in the bubble solution? Well, it makes all sorts of interesting shapes. And in general, you can ask the question of, if you have a boundary, a wireframe, and you dip it in the bubble solution and pick it up, what is going to be the shape of the bubble? And they're really bizarre looking. You can check out some of these incredible bubbles that can be created from it. But you can then ask the question, well, how do you mathematically drive that? Because I mean, if you think about what's trying to happen, we're trying to do some sort of minimization of surface tension. Okay, so there's some equations that are going out there. And it turns out that some really nice principles from physics sort of come to pop out these lovely equations, the Euler-Lagrange equations. And from that, you can solve and figure out what surface is going to occur from a particular thing. So a classic example of this is, if you imagine like two posts and a chain being hung in an arc between those two posts. Okay, so what is that arc? Is it a parabola? Is it something different? And so it's a very similar kind of question. And you can ask precisely this question, and you can plug it in, and you can drive it and get out some answers for this. So that's the video that I like about it. And to slightly toot my own horn about it, some of you might know about 3 Blue 1 Brown, who is like the biggest and well-deserving of the math YouTubers out there. Anyways, he runs sort of an annual or maybe semi-annual math competition for math videos. And so that video on the bubbles was one of the winners of that competition.
Oh my God.
And so amongst a bunch of really other fantastic videos. So I always liked it, and then it also got a bit of recognition. So I think that's my favorite video.
That is really cool.
It is cool. We'll have to check it out after.
It's nowhere close to the most like viral videos or anything like this. It's the video I wish people would watch, not ones that they necessarily do watch.
What is your most viral video?
Okay, I guess the ones at the top they're not even really should be thought of as viral. They're just standard course content that people have watched a lot. Like you type in Bayes' theorem, and so many students have done this.
Oh yeah. I've done it.
I remember one that went kind of controversial, which was right around COVID-19, and everyone was online, and I sort of dived into a little bit into the literature of academic dishonesty and what was coming out and like what people were reporting on, like what things can people do to try to have students cheat less and what are sort of the consequences. I tried to explain it all. And it was hilarious. Like most of my videos get like 99% like ratios. And this one was like 10 times worse than that, at like a 90% like ratio, like going from 99 to 90. But mainly because there's so many people had lots of comments along the lines of, well, but universities are so expensive and they're a little bit of a scam. I should just cheat. So it doesn't matter what the literature says about it, which is really interesting. So that like went viral for like kind of not the best reasons, if that makes sense. I'm like, okay, well, it would have been great if it didn't go viral, but all right. And I remember one that did really well. And I really liked it because it was the video on cosine of cosine of cosine of cosine of cosine of cosine of cosine. What happens, and if you've ever sat there on your calculator and you take any number that you wish and you just mash the cosine button over and over again, you're always going to get to the same number at the end. And so there's some sort of spiral about this that no matter where you start, you always spiral in on the same thing. And it's such a sort of surprising thing that like actually a lot of kids have gone on their calculator and done this and like might have noticed this, but like nobody really knows why. But it's this lovely theorem in mathematics, the Banach fixed point theorem. And so I really liked that video because it was able to take something that sort of went viral because everyone was like, I want to know what cos is. That sounds kind of weird and strange. But actually, we got to see a little bit of high-level math about it. So that's also one of my favorites.
And for those of us who know nothing about math, what does it go to? What is the number?
Oh, there is a number. I've forgotten what the number is. It's some long decimal thing. It's got a name.
We'll just have to watch the video.
Yeah, we'll have to watch the video to find out. What matters less is what the number is, because you could always just approximate it by starting anywhere and then pressing cosine a bunch of times. What's more interesting is the fact that there has to be a number. That it doesn't matter where you start, that it's going to spiral. And then you can ask, well, okay, that's true for cosine. If you have some other function, and you apply that some other function over and over and over again, well, when are they going to have those fixed points and when are they not? And so the theorem basically gives this condition, well, if they're nice in this particular way, then you're going to have them collapsing down to a point like this.
Would that be like convergence, like when you did like sequence and series? Is it
absolutely
similar?
It's absolutely that. Yeah, you can imagine it as a sequence which is converging. You've got your first number, you plug in 1,000,000, and then you take cos of 1,000,000, and then cos of 1,000,000, and so on. You're getting a sequence, and that sequence is going to converge.
Makes more sense as a spiral. I like that.
Yeah, go ahead.
Do you have any comments on game theory? I saw you made a video about it.
Yes. I made a little series on game theory, but nobody ever watched it. I think because...
Oh, first of all, what is game theory?
Well, at a high level, we're trying to say, if you have a game, and you can imagine whatever it is, it could be poker or it could be chess as like an actual game, but it could also be more like situations like two firms are competing in the marketplace or a couple species are competing for resources. You're basically trying to ask the question, well, what is your optimal strategy? How should you play in a way so that you can't be exploited? So if you and I are two businesses or two different species or two players of some kid's game, doesn't matter what it is, how can we decide what our strategies to play in an optimal kind of way is? And there's all sorts of things, even just the fact that under many scenarios, there is what's called a game theoretically optimal strategy. And this is guaranteed that there is a best strategy. It's not always obvious. You have some weird game with weird rules. Is there a best strategy? Well, game theory gives some conditions of when there's a best strategy and helps you try and decide what those are going to be. So it's a really cool branch of mathematics that has tons of applications in economics and so many different things, but I love it, so I have a little series on it. And I think it's actually the type of math, because it's not normally taught or required, it actually didn't get the reach that I would sometimes love a video to be able to do. But yeah, game theory is really cool. And even for myself, just to dive weirdly off topic at the end, it's the one type of branch that I most used in my real life, I suppose, in that back in the day when I was in graduate school and playing lots of online poker, nobody should gamble, of course, but back in the day, a lot of game theory ideas were actually really helpful in that case. So I think game theory is awesome.
That's cool. I mean, to be fair, yeah, it's totally not talked about enough for how, like, I mean, I think it's pretty cool. I don't understand it fully, but I think it's cool. Yeah. But there was, like, I think John Nash.
That's
I
right.
believe.
Yeah.
So he has a whole movie about himself.
Yeah, a beautiful mind. That's right. Yeah.
And that's where I learned about it, because that's a cool movie. You guys, people should check it out.
Yeah, and he won, if I remember correctly, the Nobel Prize, but in economics, I believe it was, because of how applicable that particular math was to economics. Yeah, so I teach a little bit of game theory in an upper level course I love to teach on mathematical modeling. And the math modeling course is fun because it's about trying to take math and apply it to real world situations.
Right.
And so there's many different mathematical tools that apply to real world situations, but game theory is just one of those. So I included it into that course. I really love it.
Awesome.
What other courses do you teach?
So for myself, I teach a lot of different courses, but I normally will do, like, every semester, like one big, large course for first or second year students, is like your calculus or your linear algebra. And then I really like when I also get to teach one of the, like, third year courses. So I'll typically teach this mathematical modeling course. And then my own field of mathematics, which is called Topology, I get to teach that course, and that makes me really happy, because that's
Topology.
I should have anticipated that. So, geometry is like study of spaces and shapes, but there's a certain, like, rigidity in geometry. Like, you care about, like, the length of the side of a triangle, and you care about, like, the angles that are formed. So topology is also the study of shapes, but it is sort of like you're imagining everything's made out of Play-Doh or out of rubber bands. So you're like, I can't rip things and tear them apart, but I can kind of like manipulate them in my hand. So the classic example would be if you look at a donut, which has got like a single hole, and you look at your like coffee mug with a handle that has a single hole. Well, if those were made out of Play-Doh, you could kind of like massage your coffee cup until it looked like a donut without having ripped away the hole. And so to a topologist, a coffee cup and a donut are the same thing, which sounds a little bit weird. But it allows you to answer those types of problems with a lot more sort of generality. So you're interested in sort of trying to distinguish between different spaces. Maybe these spaces are very high dimensional, but it's kind of a really fun and beautiful, sort of geometric, but without the rigidity of actual geometry. So that's the field of topology, which I really love.
Does it just retain its volume then, or not
It
even
does,
that?
in this case, it doesn't even, I would imagine a small circle and a big circle as being like the same from the perspective of topology, but it would count, for example, the number of holes of different dimensions.
Okay.
So it would consider like a ring and a straw the same. I don't know whether you want to say they have a hole or not, but one could debate what a hole really means. But that's sort of different than the center of a basketball, which is a hole in sort of a different dimension. Oh. Right? So a basketball is this like surface that encloses a space.
Yes.
And a ring also has a hole, but it's sort of at a different level. And so so a topologist would look at a ring and a basketball as very different objects. And now you're trying to carry on going. Okay, well, like what's like a 4-dimensional hole and what other properties can we retain? And so there's all sorts of really sort of lovely properties that can come out of topology. Like I'll give you just one very simple idea. Like on the surface of an Earth, it turns out that there's always a point where if you look at this point and the spot on the exact opposite side of the Earth from you, like it's antipode, like the North Pole and the South Pole, there's always somewhere on the Earth where those pair of opposites have the identical temperature and identical pressure at the same time. So somewhere on the Earth it has a temperature and a pressure, and you go to the other side of the Earth and it will have the identical temperature and identical pressure. So this is a fact that can be proven out of topology, which is kind of a crazy idea that you get these weird, interesting things that have to exist.
That is interesting.
So
I have
weird.
one final question about that.
Yeah.
But I don't remember what it's called. Do you know the four-dimensional shape that you can buy? You know, it's like a glass.
Oh,
and it's
probably the Klein bottle.
Yes.
And the spout of it sort of loops back in.
Yeah. So what about it makes it in four dimensions? Like,
oh, I see. Yes.
Yeah.
Right, because obviously the thing you've bought from Amazon isn't itself 4-dimensional.
Yes.
So, okay, you know a Mobius strip, which is like you take your little cylinder, but you give it one little twist. So this is an object that we've created that you start with something 2-dimensional, which is just like a little strip of paper. But then when you twist it and put it back together, it has this weird property that it's only one side as opposed to having two sides. And it doesn't make sense to talk about it any longer in 2-dimensional. Like it has to live in this 3-dimensional space for you to sort of authentically understand the whole idea of the Mobius strip. So a Klein bottle is very similar to this. You can start with something 2-dimensional. You can start with a square. And you imagine, well, if I rotate it around to make it look like a cylinder, but if I added a twist, it would look like a Mobius strip. And now it's a square, so you have two different sort of sets of edges. What if I twist both of those? If you try and do that, you can't actually go and glue all of this together in 3 dimensions. But if you imagine you could do it in 4 dimensions, then you actually can imagine this object existing. And then they fake it when they try to sell you the product on Amazon because they puncture themselves. They take the loop of it and they puncture back through themselves. So it's an inauthentic representation, or it's a 3-dimensional representation of the 4-dimensional object. You should be able to do it without the having to punch back through itself if it lived in 4 dimensions. That's
great. Thank you for answering all of my pressing questions.
You're more than welcome.
Okay. Well, do you want to plug your channel a little bit?
Sure. Well, you can always search my name, which is at Dr. Trevor, and find out about my channel. And I would love to see anybody who wanted to check things out.
Join us next week where we're going to be chatting with Dr. Mark Laidlaw.
Bye.
Bye.